Yeah, pencil. Ready? All right, do you guys agree with that?
Yes.
Okay. What about do you agree with that? Yeah? Understand that? Okay. No? You don't believe me?
I believe.
You do believe it?
Don't believe it.
Uh-oh. You want to prove with numbers? Let's say we have like, you think that's equal to, so the square root of 13 is the same as 2 plus 3?
Yeah.
Wow. Okay. So, let's think about the sine. Oh, no, now we're back to that. Does that equal the sine of 30 plus the sine of 60? Okay. Probably not. Going along with our trend here, right? There's a pattern. So let's think about it. 30 plus 60, that's 90, right? What is the sine of 90? 1, good. Yeah, and this, yeah, that's definitely not 1, right? Okay. So we have some formulas that we can use to figure out angles that we want to add together. Because right now on your unit circles, those are the only angles we can do, right? We can do anything that's 30, 60, 90, 45, but that's it. What if I want the sine of 15? Okay. What if I want the sine of 75? Out of calculator. Yes. 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 Approximate. You can get pretty close. We try. All right, we are actually going to do some formulas. So in your packet is where it all, like, there's a way to derive it. There's a big rectangle page in there. But that's going to take a long time, and we don't have a long time today. So the first one. If I want to do the sine of alpha plus beta. Okay, alpha and beta are just your two angles. So like we were just doing, the 30 and the 60. This is equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Okay? Yes, that is true. Yes. You'll see a pattern here very quickly. What if I want to subtract? What if I want to know the sine of like negative 15 degrees? Okay. This is beta. There's a fish in there.
Well, on our paper, it doesn't.
I know. Remember I told you guys to do this on a blank page? These are different than the ones that are in your packet, okay? I mean, the ones in your packet are fine. This is just a more straightforward approach. The big rectangle thing in your packet, that's where these all come from, and we can derive it, but we're going to just look at our formulas to start with. So those are your two formulas for sine. Very similar, right? Add, you add. Subtraction, you subtract. Okay. Let's do cosine.
Yeah.
So we're going to do cosine of alpha plus beta. Do you think it's going to look exactly like the sine? Probably not. Cosine alpha, cosine beta, minus sine alpha, sine beta. Okay. Cosine always has to be difficult. Cosine's like your x value. That's always trickier with the x's than the y's.
So would it be correct to say that that sine beta is equal to cosine of alpha plus beta?
No, because if you look, this one's sine cosine, this one's cosine cosine, so they're not the same. So what do you think it's going to be for cosine of alpha minus beta? Yeah, so it's going to be cosine cosine plus sine sine. What? I'm sorry. You can just use A's and B's if you want to. Okay, so what have I forgotten now? Tangent. All right. Okay, so this is tangent of alpha plus tangent beta over 1 minus tangent of alpha tangent of beta. So you strongly dislike this? Okay. So what do you think it's going to be for tangent of alpha minus beta?
All the signs are.
Yeah, so that's your numerator will match, so it'll be tangent of alpha minus tangent of beta over 1 plus tangent alpha times tangent beta. We aren't going to write the formulas for cotangent, secant, and cosecant. What you can do is find it as sine, cosine, or tangent, and then do 1 over that, and simplify if you need to. Okay, so we don't need both of them. Yay, we'll pause for lunch. After this. You guys are loving it. Does everybody have the formulas written down? Got them?
No. You need to bring myself to practice Unacceptable.
All right, the rest of us are going to keep going. All right, guys, so let's do our first example here. I want you to find for me the cosine of 15 degrees.
So then for cotangent,
You actually know. So could I like subtract 2 angles to get 15 degrees?
Big machine, bro. I'm not helping you.
45 minus 30.
Got it. All right, guys, I'll walk you through this. I'm going to pick 45 minus 30. Do you have to pick those two angles? Lots of options. So this goes back to you knowing your values from your unit circle. What is the cosine of 45? Cosine of 30. Cosine of 30. Sine of 45. Sine of 30. Alright. So you should be at root 6 over 4 plus root 2 over 4. So you can combine that just to root 6 plus root 2 all over 4. Yeah? Yeah. Okay. One done. That's it. Nice. Let's do... Sorry, I'm looking at what else I want to give you. All right, guys, they are not always going to be in degrees. All right, so sine of 7 pi over 12. So let's think about your circle, because there's an easy way to do this. I don't want you to convert and turn it into degrees every time. I want you to be able to think around your circle. So would you agree I've got pi over 6, pi over, that's a 4, pi over 3, pi over 2, like we know this, right? What would be a common denominator for all of those? 12. So isn't pi over 6 just 2 pi over 12? And pi over 4 is 3 pi over 12. And pi over 3 is 4 pi over 12. 6 pi over 12. Okay, so you guys try it. You're trying to get to 7 pi over 12. No, you don't have to count. You have enough already that you could add 2 together to get that, right?
6 pi over 12 plus 12.
I would not do 6 pi over 12 plus 1 pi over 12, okay? Because pi over 12 is 15 degrees, and you don't know anything about 15 degrees. You did cosine 15 degrees. And I would not recommend that you do it. Guys, why not do 3 pi over 12 plus 4 pi over 12? Yeah. Always go back to stuff you actually know from the circle.
So, we're not supposed to convert it to degrees.
I want you to be able to think in radians. You got to be able to think in fractions. Do it.
It's harder because you don't have to calculate. Yeah, calculators.
So guys, do you agree that this is just sine of pi over 4 plus pi over 3, right? Pi over 4 is 3 pi over 12. 4 pi over 12. Are you with me? I am not sure you are with me. It looks like you're eating hand sanitizer. What is going on? Bad taste in your mouth? No? Okay. Just checking. This will be fun for anyone who watches the video. I am recording. So guys, your formula, sine of pi over 4 times what? Don't say cos. What is it? Sine pi over 3. Then is it plus or minus? Plus. plus what?
Cosine of pi over 4.
Thank you.
Sine pi over 3.
Yeah.
I don't know either.
I don't either. All right, so sine of pi over 4 is root 2 over 2. You guys are gonna know them. You said you'd have one of those quizzes this week, and you haven't had one yet. So. You have to just know.
Is it gonna be converting or is it gonna be?
It's gonna be like this with the cosine pi over 3. You'll have 3 minutes to do 20.
It's like sine now.
Tangent, secant, cosecant, cotangent. Yeah.
And numbers that wouldn't be on.
Good. Like figures and could be, yeah.
That's not nice. Based on values, can you add another like 5? Yes. Like pi over 7.
That is so cool. I just told
That's like
20 questions.
It's the same.
All right, guys, what do you notice? It's the same. There's absolutely a pattern here that you can start to recognize. All of your answers when you're doing these with sine and cosine are going to have a root 2, a root 6, and an over 4. The signs will be different. Sometimes they're both positive, both negative, sometimes negative root 2, sometimes negative root 6. Okay? You can start to look for it and see if you can figure out the pattern. It's very quick if you can figure out the pattern. I'm not going to show it to you yet. I'll show it to you next week. Oh gosh, and I only see you on Friday next week, guys. Remember, next week's really weird. No school Monday and then PSAT Wednesday, so I don't see you. Whenever I feel like it.
So like next week, so expecting on Fridays since it's the only day we see.
Give us a warning this week. Yeah, I won't always give you a warning. It'll just be whenever.
It's the same.
All right, let's try one more of these. We'll go back to degrees for you. All right, guys, tangent of 105 degrees. My tip for you when doing any of the tangent ones, so let's think about it. What is tangent of 30 degrees or pi over 6? No. What is the tangent? Root 3 over 3. Okay? When it's 30 degrees or any of the over 6s, the tangent is root 3 over 3. Positive, negative, all of that. What is it when it's 60 degrees?
Well, I know that 1045 is 1.
Good job. Tangent 45 degrees is 1. What is it when you're up at 60 degrees? No. Just root 3. What do you think is going to be easier to work with in this formula? Root 3 over 3 or just root 3? Just root 3. So whenever possible, avoid the 30 degrees or the pi over 6s. Okay? It'll make your life easier. So like I would not do 135 minus 30 for this one. Okay? I might do 60 plus 45. Yes. You guys try this one. Let's see what you get. It will not be exactly the same as the sines and cosines were. Okay. Tangent of 45 is best. Yep.
Oh, is it just three?
How we doing, guys? Do you have an answer? What'd you guys get? -2 minus √3? Yes. Anybody not get? No. Okay. All right. So I'm going to do tangent of 60 plus 45, right? So that's going to be tangent of 60 plus tangent of 45 over 1 minus tangent of 60 times tangent of 45. We're okay with that? Yes? Okay. What is the tangent of 60? √3. What is the tangent of 45? 1 minus √3 is 1. We're okay to there? Yes. Okay. I'm going to rationalize. What do I do? Yes. Okay, so my numerator, if I multiply this out, I'm going to get √3. I'm going to get a 3. I'm going to get a 1, and I'm going to get another √3. So what do I actually end up with? Plus 4. Okay. Are you guys okay with that? Okay. What do I get in the denominator? I get 1 plus √3 minus √3 minus 3. So what's 1 minus 3? -2. So then I'm just dividing everything by -2, and I get -2 minus √3. Yes, no, maybe? Where'd I lose you? Didn't like my multiplying? Numerator or denominator? Okay. So if I actually multiply this out, that's √3. That's 3. 1. √3 times √3 is 1. And then down here I've got 1 plus √3 minus √3 minus 1. All right, we okay? We have, what do we have? 2 more examples? 3 more examples? We can get through this. All right, the next one is super easy once you see what we're doing.
This one.
Okay, so we're working in reverse this time. So sine 80 cosine 20 minus cosine 80 sine 20. You need to look at your formulas and see which one you think this is. First, is it a sine or a cosine formula? Sine. Sine of a plus or sine of a minus?
Minus.
Okay. So would you agree this is really the sine of 80 minus 20?
Yes.
Which is 60, which is root 3 over 2. Yeah? Is that one simple? Okay. All right. So guys, this next one is like the proofs you were doing, but you have the formula to guide you through the proof. So it would say like establish the identity. So we're going to have cosine of alpha minus beta over sine alpha sine beta equals cotangent alpha cotangent beta plus 1. This is a proof. Which side do you think we want to work on?
On the left.
I would work on the left because we can start with a formula, right? So cosine alpha minus cosine beta, what is that? What is that?
Beta plus sine alpha times sine beta.
All over. You're okay with that? And then we split it, yep.
So you get plus 1.
So,
Yeah.
cosine alpha, cosine beta over sine alpha, sine beta.
Oh! 2 cotangents plus 1.
And then plus sine alpha, sine beta over sine alpha, sine beta. You guys with me? Just splitting up the fraction, making 2 fractions out of it. So what do you think, guys? What's cosine alpha over sine alpha? Okay. And then cosine beta over sine beta plus 1. That whole thing just reduces to 1. And what's left? I mean, you basically just do it in reverse. You have to turn both cotangents into cosines over sines. Do you see what I mean, though, that that's a little easier than the other proofs because you have an idea of exactly where to start with the formula? Yeah? Maybe? Can we just look at it? All right, guys. We're going to do one more. Are we okay with that one? Any questions before we move on? Okay. Okay, you are given that the sine of alpha equals 3/5. 0 is less than alpha is less than pi over 2. This is really not bad. It looks scary. It's not. It does. I agree. It looks really like what? Cosine of beta is 5 over 13. 0 is less than beta is less than pi over 2. And we are going to find the sine of alpha plus beta. Okay, we need to make a couple of pictures. So I'm going to draw a little triangle up here in a coordinate grid for alpha, and then I'm going to draw another one for beta. So remember, alpha is just your angle. I'm telling you it's somewhere in between 0 and pi over 2. So what quadrant is that? First. So we're drawing a little right triangle in the first quadrant, just like you did in Unit 1. There's the right angle, so here's alpha. And I know the sine of alpha is 3 over 5. So what does that tell me about my triangle? Radius is 5. Where's that 3 go? We know 4 is your okay. Now we need a picture for beta. What quadrant is beta in? First. Do you think they're all always going to be in the first quadrant? No. If they're not the first quadrant, be careful with your signs. Alright, so there's beta. So what do I know about this triangle?
Radius 13.
Radius is 13. 5 over there, 12 over there, right? Okay, so far not bad, right? Nothing new. Okay, we have sine of alpha plus beta. We've got a formula for that, right?
What is it? Sine of alpha.
Sine alpha cosine.
Beta.
Plus. Plus cosine.
Alpha times beta.
So you guys already know them, right? Kind of.
I don't remember. I have to look at it.
Okay, so now you've got these two pictures where you can find these sines and cosines from. So what is the sine of alpha? 3 over 5. What is the cosine of beta?
550.
Okay. Plus, what's the cosine of alpha? 4 over 5. And the sine of beta? 12 over 13. Okay. Fractions, we multiply straight across. So I have 15 over, what's 5 times 13? 65. I wouldn't reduce, because if you reduce, then you're going to have to turn right around and find a common denominator.
Yeah.
Plus, what's 4 times 12? Over, which, when you add them together, equals. Okay. So the sine of alpha plus beta is 63 over 65. Right? Doable? You can draw pictures. Okay.